Number 1, 2-2B, constant of proportionality. You have just purchased 15 songs on iTunes for $19.35. What is the constant of proportionality? Well, I can figure that out by putting $19.35 over 15. I'm comparing the cost to the songs. So I've got my ratio, and I want to know how much one song is. Well, 1935 divided by 15 is $1.29. So the constant of proportionality is $1.29 to 1. Using a ratio or an equation, show just how much 33 songs would cost you. Well, the cost is equal to $1.29 times the number of songs. There's my equation. So the cost equals $1.29 times 33. So the cost equals $42.57. Or you could have just done 33 times $1.29 equals 42.57. Either way, we got a formula or we got an equation. It's the same thing. Timothy is cutting lawns to earn money. He cut 3 lawns last week and may be able to add 3 accounts or 3 more this week. If he continues to add accounts at a constant rate, how long will it take him to get 12 accounts? Well, last week was the first week. He did 3. If he adds 3 more this week, he'll be at 6. That's week 2. If he adds 3 more next week, that's 9 at 3 weeks. And at 4 weeks, he'll have 12. I've completed the table. I'm going to circle the constant of proportionality. Done. How long will it take him to get 12 accounts? It will take him 4 weeks to get 12 accounts. Number 3, 1-3C, multiplying integers. Write each expression as an equation. Equation has an equal sign and an answer. So negative times a negative is a positive, so 5 times 2 is 10. Positive times a negative is a negative, so 8 times negative 2 is negative 16. 4, 1-2C, properties of numbers. Write the letter on the line that best describes each step. And the key to solving these types of problems is to look at what's happening here and then look at what's changed. So the first thing I see that's changed between here and here is this is now a 6, and instead of a quarter, this is 3/4. So the 3 was distributed, so that's what's changed, distributive property. And then between here and here, what's changed? Well, subtraction of a negative is the same as adding the opposite, and so that's what they've done here. That's A. The difference between here and here is we've got the thirds grouped together and the fourths grouped together. That's B, commutative property of addition. And then we've added an inverse here, okay? And now we need to add. Number 5, adding, subtracting rational numbers. Model each expression on a number line. Write each expression as an equation. So I need a model and an equation. Well, I'm going to solve this right now. Get my equation out of the way. Positive 2/10 subtracting 3/10. Well, that would be negative 1/10. My model, it's 0, 1/10, 2/10, 3/10, 4/10, 5/10. I'll put 0.5 on here. This is 1/10, 2/10. Over here, 1, 2, 3, 4, 5. Negative 5/10. Negative 1/10. All right, so I need to go to positive 2/10, and I'm going to go back 3. So I count 1, 2, 3. So I'm going to go back 3 because I'm subtracting, and there's my model. Number 6, 1-1D, adding and subtracting rational numbers. Model each expression on a number line and write each expression as an equation. All right. Well, 3/2 minus 1/2. 3 minus 1 is 2. So I'd have 1 and 2 halves. And I think that's the easiest way for me to think about it. So I've got 0, I've got 1/2, 2 halves, 3 halves, 4 halves. 1/2, 2 halves, 3 halves, 4 halves. I'll do the same thing over here. 1, 2, 3, 4. Negative 1/2, negative 2 halves, negative 3 halves, negative 4 halves. Okay, and so I've got to go from 0 to negative 1/2. Then I've got to go 3 halves, 1 and 3 halves in the other direction. Well, this is from here to here is 1/2, from here to here is 1. And then I need to go to 2 halves right here. Let's see. So it would be 2. So this is 1 and this is 2. Because 2 over 2 is 1, so that equals a positive 2. So if I go from here to here, I'm at 2 or 4 halves. B, negative 3.5 plus 1.5. Well, that equals negative 2. So I'm going to break my number line up into halves again. So 0, 1/2, 1. 2 halves, 2, 2.5, 3. Need to go a little further. 3.5. So my number line goes from 3.5, from 0 to 3.5. And I've got to go back 1.5. Well, from here to here is 0.5. And so from here to here is 2, or 1.5. Negative, negative, negative. And I'm done.